Okay, and so the difference in these is the difference between a Bronsted-Lowry base, okay, so that's that first one, and an Arrhenius base. Okay, so Bronsted-Lowry on the left, I guess on the no, on the left is what I was talking about before. So this definition of acid and base is a substance that can donate an H plus ion. Okay, so we've got our classic acids in that case, hydrochloric acid. It's got an H plus ion sitting there next to the chlorine, so it can donate it. But a base is not necessarily something that can accept an H. It's not has nothing to do with having hydroxide. It's just something that can accept an H plus ion. So the things with hydroxide still count, but are things like NH3, where it really likes to get that extra H plus and become NH4 plus, ammonium. That is the type of base that ammonia is. It's a Bronsted-Lowry base. Arrhenius bases and acids, defined over here, are the kind of stuff that we're mostly going to be focusing on, which is just an acid, which is something that has the H plus, and a base is something that has the OH minus, the hydroxide. Okay, so this is where all the strong bases that we learned about fall into this category. Okay, so down here, an example, sodium hydroxide. It's got the hydroxide there, it's a base. Hydrochloric acid, it's got the acid there, or it's got the H there, it's an acid. Okay, so we're not going to worry too much about Bronsted-Lowry bases and acids. We're mostly focused on Arrhenius acids and bases in this course. Okay? So, pH scale, this is something you've probably seen before. This is basically just a way to measure how acidic or basic something is. Okay, and you can see the actual scale over here, where lower numbers, it's a little confusing because the lower numbers are up top, but lower numbers are more acidic, higher numbers are more basic. And it goes from, this scale goes all the way to -1, but essentially mostly goes from 0 to 14. So pH is literally a measurement of the concentration of H plus ions in solution. So this is basically, if I poured a bunch of acid into into water, remember that acid, if it's something like HCl, will split into an H plus ion and a Cl ion, and so you'll have a bunch of these H pluses floating around. And so if there's a lot of these, it'll have a very low pH. Okay? And in fact, here's the mathematical definition. You'll see it's a little confusing because it has a minus in front. But basically, all you have to remember is low pH means acidic, high pH means basic. Right? pOH is basically just the opposite of pH. pH is a measurement of the hydroxide ions in solution, and so pOH is low when there's a ton of base, when a solution is very basic. So it has the opposite relationship of pH. Okay, there's the mathematical definition. You don't need to worry about that. In pure water, so this is something we think of as completely neutral, pH and OH are both 7. Okay, and you can see on our chart here, 7 right in the middle. It's even labeled as being neutral, and you've got pure water right there. Okay, so to be clear, the ranges are for pH 7 to 0 is acidic, and from 7 to 14 is basic. Okay, And POH is just the opposite. In fact, you can get in between them by knowing that they should add up to 14. So if something is incredibly acidic, it'll have, if it has a pH of 1, you can see that's up here. That's, around battery acid and lemon juice. Extremely acidic, sour things. I mean, don't drink battery acid, but it would be very sour if you did. You'll have a very low pH of around 1. That means the POH is around 13 because they need to add up to 14. Okay, and so having a very high POH means that it is very acidic. Okay, so these are a little confusing, but as long as you remember that they add up to 14 and that acids are low pH and bases are high pH, that's all you really need to know about the pH scale. And you, again, don't need to do the math to figure out how to calculate pH. That's for chemistry. All right, and then our final thing is just to be explicit about neutralization reactions. So the neutralization reactions are things that we were talking about earlier in the notes, but it's basically the classic reaction of an acid plus a base yields a salt and water. Okay, so this is what I was talking about before, of pouring two, quite potentially harmful substances like an acid and a base together and coming out with something quite not quite inert, like a salt and water. Okay, so this sort of has, this is a special kind of reaction. It's known as a double replacement reaction. We'll learn more about that later in the unit. But it's always going to have these 4 components. Okay, so we've got 2 examples down here. So we've got the classic example here, hydrochloric acid, so HCl. Classic, very dangerous acid when it's concentrated. Can dissolve a lot of things, very reactive. And sodium hydroxide. I believe you see that a lot as drain cleaner. Very caustic, very reactive. And you neutralize them in equal amounts, and what you get out is water. So, extremely, well, in your case, unreactive, and Na, sodium chloride, salt, so that's just table salt. Okay, so in this case, your acid is on the left, your base is on the right, there's your water, and there's your salt. Alright? In this case, down here we have nitric acid and sodium hydroxide. Here we have a polyatomic ion going with the H to form the acid, but it's the same thing. You take the H and the OH and you put them together to make the water, and then you take the 2 things that are left over, so the end of the acid and the beginning of the base, and put them together, and that makes the salt. Okay, so it has this sort of general formula of HA, where A can be anything, plus BOH, where B can be anything, makes BA plus water. Okay, where the hydroxide and the hydrogen made water, and then the other 2 things that are left over link together and become a salt. Right, this thing BA here is referred to as the salt. Okay, so that is our complete series on acids and bases. That was a long video, so I'll definitely split it in half. And yeah, we will spend some time getting our heads around this and practicing it in class, and I will see you there.